16 on June 2019. Speaking of passing through a point. All right, let's do this. All right, so if you're asked to write an equation of the line, you need two things. You need the slope and you need the y-intercept. And if we're using symbols, m and b, and y equals mx plus b. All right, so let's talk about the slope. We're at an equation of a line that is parallel. Let's start it off. What if two lines are parallel? Slopes are 10. Slopes are same. So what I need to do to negative 2x plus 3y equals negative 4, I need to figure out what the slope is. Can't do it unless it's in y equals form. Start it with me. Get it in y equals form. 11. Add 2x over. So I add 2x over. (3y) equals 2x minus 4. Next. 5. Oh, we just got here, Greg. Be prepared for the next one. 8. Getting it y equals. Divide the 3's on every side. Y equals 2/3 x. Honestly, I don't care what the y-intercept is. I'm not interested in it. Doesn't matter what it is. The fact that the slope here is going to be 2/3 and the slope of my new line is also going to be 2/3 because they're equal. How to find the y-intercept? Y equals mx plus b. How do I find b? Well, I already know m is 2/3. Y and x are a point it goes through. So what's the point it goes through on this one, they tell me? 4. Griff, what point does it go through? 1, 3. So 3 is the y coordinate. 1 is the x coordinate. Let's solve for b. 3 equals 2/3 plus b. Use your calculators. Get the 2/3 over. And you should have b equals 2 1/3. Come on, you're better than that. That's 9/3. 7/3. How's that look? 7/3. All right, so if I was right, I'm not even looking at the multiple choices yet. I'm just pretending this is a part 2 or 3. Y equals 2/3 x plus 7/3. All right, that is my answer in slope-intercept form. But unfortunately, if you look at the choices, they're not in slope-intercept form. These are all in what we call point-slope form. Point-slope form. So what am I going to have to do to each of them to see if it matches y equals 2/3 x plus 7/3? I'm going to have to get the y by itself. So to each one of these, I'm going to have to distribute first. So just by distributing, I already know 1, you're not the answer, and 3, you're not the answer, because I'm going to get negative 3/2 x, and we know the slope's 2/3. So that's out. Now I just got to figure out which one, when I solve for y, gives me a y-intercept of 7/3. Eva, how's that look? Okay. Thanks. I appreciate it. Others, multiple choice. You want to go over? Yes, Lauren, let's go.
Number 5.
5. What's 5 looking at here? All right, here's the deal. I don't need to do D and D prime because whatever the scale factor is for C and C prime, it's going to be the same for D and D prime. And I'm doing it through the origin. So here's C. I dilated it by a certain number, which is what they're asking me to find. Here's C prime. Question number one, getting further or closer to the origin? Further. Everyone understand why I'm eliminating those two? Yes? Because scale factor bigger than 1, I get further away. Scale factor less than 1, I get closer to my point I'm dilating around. So now is it 3.5 or is it 3 that I'm dilating by? Well, I got to figure out how this distance compares to that distance right there. Okay, is it 3 times further or 1.5 times further away? And I'm sure you could take a look at it and it's going to be 1.5, but just if you wanted proof, mathematical proof, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 6 over 4. And then I go 9, I think it was, and down 1, 2, 3, 4, 5, 6. Whether I go 6 over 4 or 9 over 6, it's going to reduce down to 3 halves. Good. Anything else? All right, let's get to it. Let's go to question 32, another coordinate geometry one. Am I grading your Regents? Nope. Organize it and make it neat. All right, I've seen some of the handwriting and I've dealt with it. That's part of my job, but somebody sees a bunch of scribble, a bunch of higher, and then I just blanked on that. Hieroglyphics, thank you. They're not going to be patient with it for another. I certainly won't be. If I see that from another student, I'm not going to be patient and trying to find out where everything is. Organize the darn thing. If you want to graph the trapezoid or the quadrilateral, go ahead. I think it's on the next page is the graph. So go ahead a minute. A, B, C, D, connect them. And when you're ready, get your cold hard fact sheet out because you may not know what a trapezoid has and you're going to need to know if your number pops up. All right, let's do this. I got to prove. First thing I got to do, it's a couple questions here, but the first thing is prove it's a trapezoid. So I need to make sure one of the properties of the trapezoid exists here, and there's only one property. This is not isosceles. I'm not asking isosceles trapezoid. Prove it's a trapezoid only, and there's only one property of a trapezoid. All right, all the others belong to isosceles trapezoids. There's only one property of a trapezoid, which is 15. When you find it, let me know. Parallel sides. That's it. Show it's got a pair of parallel sides and it's a trapezoid, and we're done. Just by looking at your graph, my graph, what two sides do you think we're going to try to prove parallel to save ourselves some time? 15 again. AD and BC. What formula am I going to need to show they're parallel? Come on. 19. If show two lines are parallel, what formula am I going to need? Slope formula. So slope of AD, slope of BC. Now I say formula, yeah, that could be y2 minus y1 over x2 minus x1, or you could just count on your graph rise over run. Either one's fine. and we cross our fingers and hopefully they're the same, because they should be if they're asking us to prove it's a trapezoid. So make a decision. Change in y's over x's or rise over run. AD and BC. And I'm not even too sure what's happening in some of those Chromebooks, but hopefully it's this problem. Because I don't want anybody to come crying, why did I do so bad on my math Regents? Probably because you didn't prepare and just sat there while we were reviewing. All right, what do you got for me? One, Meg, got any slopes at all? I don't need AB though.
AD, sorry.
AD, yep.
Rise 6 and run negative.
For a slope of what? -3. Good. I'm not even going to ask anybody about BC because it should be -3, right? It should have been 9 over 3. -3 as well for BC. All right, next up. That very next step. What did you just prove then? You didn't prove it's a trapezoid yet. By showing me AD and BC had the same slopes, what did you just show me? 6. What do we know now? Good. AD parallel to BC because slopes are equal. Now you know it's a what? I proved a pair of sides parallel. Now you know it's a trapezoid. ABCD is a trapezoid because one pair of opposite sides parallel. Good enough. Trapezoid. Good, Avery.
Would we also be able to just write AB's parallel to BC, or do we have to right now?
Say that one more time.
Would we be able to write AB as parallel to BC, like because AB is parallel to BC, or do we have to write out because one pair of opposite sides?
Oh, that's fine. Yeah, that's fine.
Okay.
Yeah, that's fine. Next up, it's a part 2 question. Second one, second part. Riley says this might be an isosceles trapezoid. The way he or she is going to prove it is congruent diagonals. Show that it's not using congruent diagonals. Okay, so you have to use, you can't use anything else. You have to show the diagonals are not congruent here. Name a diagonal. First. 2, name a diagonal, Matt. Okay, AC. How in the world are we going to figure out if AC and DB, the other diagonal, are congruent or not? What are we going to need? 1, what are we going to need, Meg? How do I show those 2 diagonals are not going to be congruent? Distance formula. Yep. Or Pythag. And I didn't lose it. I was just a little frustrated second period because I said or Pythag. And somebody said, where's your right triangle? Which tells me that every time I said and Pythag, nobody knew what I was talking about. If you want to find AC using Pythag, make a right triangle out of it where AC, take a look, is the hypotenuse. See that? A squared, B squared, C squared. That's what you mean. That's what I mean when I say Pythag. Every darn time distance formula gets brought up. Or use distance formula. I don't care. But you better make a decision before June 21st. So distance of AC, distance of BD. Hopefully they come out to be different, but correct. But correct. When you have one of the distances, let me know. Purposely covered it up here. When you have one of the distances, let me know. 21, when you're ready, let me know one of the distances.
AC is third, 98.
Yep. Square root of 98. AC, square root of 98. Good job, though. Square root of 98. And then when you get BD, let me know. 7.
Square root of 80.
80.
Yes.
8 squared, 2 squared.
I know what I did wrong.
Okay. Let me know when you're ready.
68.
68. Yep. Question came up. Should I simplify them? It doesn't ask. I would be a hero. Because if you simplify and you make a mistake, we do have to take a point off. Okay, so I would just leave it. Doesn't say to simplify it. Don't bother. Don't try to be a hero and make a mistake. All right, so we can say this is not isosceles. Riley was incorrect. Or just disappear on me. So one more step. ABCD is not isosceles because diagonals are not congruent. That's how you can finish that one up. All right. Any issues? Next 5 minutes, I'm giving you guys the opportunity to look over and see what you can do with number 34. Okay, you got 5 minutes, 6 minutes. Okay. I don't know if anybody did it differently. Let me know. Since the big one's a right triangle and the small one's a right triangle, we're going to find side y and subtract it with side z. And I get side x. I'm hoping, and somebody tell me why, you cannot perform sine, cosine, tangent on this triangle that x belongs to. Why not? It's not what? It's not a right triangle. Sine, cosine, tangent exclusively for right triangles, that's not. So that's why I have to involve the other two. Now, how do I find those values? Tangent. Both of them. Tangent ratio. All right. Tan 38.8. See you. Get after it. Yeah. Oh, deuces. See you later. Yeah. 30. Yeah. Way to go. Why don't we take a selfie of it later? Tangent of 38. Sorry, too embarrassing. Tangent of 38.8. Got me off my game now, Ellen. Equals opposite y over 440. I'm just preparing myself because I know that's what my life's going to be like in a couple years with my two girls. So we're already YouTube and like my youngest, who's in kindergarten, thinks she's like a YouTube like video star. And yeah, can't wait for those days. Tangent of 30 for z equals z over 440. And then I'm subtracting them. And I believe the final answer was 100 to the nearest foot. 100. Did anybody try to use law signs? Because that is another possibility. Or, and this is it would be real tough, but it's doable. Did anybody try to use your 30, 60, 90 rules maybe to find Z? Yeah, you did.
No, I was asking, are there going to be any questions on the Regents where we're going to have to use loss signs or law cosines?
No. That was an extra honors topic I did with you. Anything should be able to be solved by sine, cosine, tangent. Okay. Now, sometimes could it be quicker to use law signs or more convenient? Yes, but they should be able to be solved by sine, cosine, or tangent. Good question. Anything else? We're all good? All right, I'm going to end it today with yes, approve. 35. We've gone over congruent triangle proofs. I think it's time to coordinate geometry proofs. Whew, all right, all the givens are in now. Anybody know what type of proof this is from the proof statement? Paul? Means and extremes. But to do means and extremes, what do I need? Similar triangles, done. The similar triangle proof. I notice it's means and extremes, similar triangles. I still have a huge problem though on my hands. I have a lot of triangles in that diagram. How do you and how do I figure out what two to prove similar? Where's that going to come from? How do I figure that out? I know it's going to be similar triangles, and at the end I'm going to write product of the means equals product of the extremes, but I still don't understand how to find what two triangles prove similar. Or do I just guess? Anybody help me? How do I figure out which two? Anything here? 12? Any thoughts?
You can look at the sides and the proof statement.
There you go. Done. TA, HA, HE, and TH. Those are going to belong to two. Those four sides will belong to two triangles. You just got to find them. Okay? Those four sides in the proof statement will belong to two triangles only. So find them for me and let me know what it is here in a second so we can prove them similar. $21, when you think you have those triangles, let me know. What? Oh. 22. Yep. Got it. Right here, these back-to-back ones here. HEA along with HTA. If we're doing a proof, what's the only way we're going to prove these similar? One, what's the only way, Meg? Proving triangles similar. They're usually three methods, but when you do a proof, let's be honest, we're only going to use one. Proving triangles similar. There's three methods, then there's a main way. Go ahead, look it up. We'll remember it next time.
Side angle, side.
We're going to prove the sides in the same ratio. I need numbers to do that. There should be a main way. Okay, here we go. Angle, angle. Angle, angle. Can we get the first pair of angles out of the way? The easier pair? Because it's already really given to you. 15. What pair of angles do you have for me up here?
Angle HEA, HAT.
Yep, those are right angles. I just remember I got to say the right angles first before you tell me they're congruent. So angle HEA and angle HAT. Well, that spells hat. Way to go. Great job. Perpendicular lines form right angles. And then you can tell me in the next step they're congruent. Wow. It's been a while since we've written these. Right angles are congruent. Now, this is why this is a 6-point proof. Where are the other pair of angles located? I don't care. Don't give me reflexive side. I don't need side. We need angles, don't we? We need angles. But remember, the givens are there for a reason. To use every single one of them. So why on earth did they give me HM is congruent to AT, HT is congruent to AM if this is an angle-angle proof? Okay, I'm not proving triangles congruent, so why in the world would you give me that? Lauren? Look at math now. Look at quadrilateral math. Aren't opposite sides congruent? That equals a parallelogram. Yes, there's the key to this whole one. Math, how creative, is a 11-ogram. 11 parallelogram, relax. Why? Why is it a parallelogram? I know we just went through it, just want to make sure. 14, 17, why is it a parallelogram?
Because two pairs of opposite sides are congruent.
Opposite sides congruent imply a parallelogram. So, how's that getting me another angle here? It's a parallelogram now. How does that lead me to a final pair of angles? Whoa! 5. There we go. Opposite angles are congruent. So T would be congruent to M. But there's a problem with M. What's the problem with M?
It's not in triangles.
Okay.
So,
Oh, true. Are those full angles in my triangle? Okay. So that's probably not going to help me, right? But you can, and again, you can say that. I just don't know, Greg, how having those two right there, and they're not even full angles in my triangle congruent, right? So that I probably need to go another property here. Another parallelogram property that has something to do with getting me angles congruent, not sides. Angles congruent, not sides. What do you know about opposite sides? They're congruent, and what else, Greg? In a parallelogram, opposite sides are congruent, and they're also, and what do parallel lines sometimes lead to? Specifically, I'm going to make this tough for you. What are those angles called in this case? If I have MA parallel to HT, what type of angles do I have here? Alternate interior angles. That's where I'm getting my third pair. Everybody good? First thing you got to tell me, HT is parallel to MA. Parallelogram implies opposite sides parallel. Then you can tell me the alternate interior angles are congruent. That's how we got to it here. THA congruent to HAE. You remember this reason? We haven't used it in quite some time. Paul? Good. Parallel lines imply alternate interior angles congruent. And now you could say the triangles are similar, right? Triangle HAT. Make sure you write similar. God, how bad would that be? You wrote congruent, and there's your 99. Oof, brutal. Brutal. HAT similar to, if I go HAT, AEH. Yeah. We're not done though. Oh, means and extremes don't come now. There's an in-between step. Prove the triangle similar, in-between step, then means and extremes. What do you need to have means and extremes? They don't exist yet. Where are they going to exist? What do I have to write next? Proportion. Means and extremes only exist in a proportion. That's what this next step is. Where do I get that proportion from? To make it easy, the proof statement. TA. If I'm going to put TA here in the top left, where does HA have to go if I'm going to multiply it with TA? Where's HA have to go here? Let's roll 8.
If TH is there, then HA has to go on the bottom of the second.
Good. And the other two can go in the other two spots, HE and TH. Why? Why? Oh, Charlotte, keep going.
When you do the product, you need to divide it with the exchange of the cross because you're cross multiplying.
Well,
And so they have to be like a cross.
no, why is this proportion true? That's what I'm asking. What's my reason for this proportion to be true?
Oh, because CSS.
Oh, okay. Look at that. Oh, that's what it was called. Corresponding sides, similar triangles are proportional. Then we could say means and extremes are equal. That is a solid 6-pointer right there. Solid 6-point proof. For Monday, part 2s of this exam. Part 2s. Monday, part 2s of this exam. I'll take questions on. And I will be going to January 2019 on Monday. All right, January 2019 will start being worked on. All right, remember, we don't go through every single question, so you can always go back and try problems out when you start studying it, for real. Part 2s I'm asking for over the weekend. January 2019, we're going to start working on Monday. 15 multiple choice question quiz on Thursday. 6 days of review down.